Hello everyone, I am Deepak and I have been teaching Quant and DI for the past 16 years for various competitive exams. Today we have the topic of basics of variation. So let's see what the overview of this session is. Overview says we need to discuss the concept of direct and indirect variations, then equation of variation and constant of variation, followed by some concept based questions, and finally we have some practice questions and their answer key. Let's first of all go to the concept. So we have a question with the help of which we'll explain the concept. It says distance traveled by a vehicle is directly proportional to its speed, and when the speed of the vehicle is 30 km per hour, distance traveled is 90. What would be the distance if the speed is 60? We'll move to the first thing. It says distance traveled by the vehicle is directly proportional to its speed, which means we'll write distance is directly proportional to speed. Now this particular sign is what we call as sign of proportionality. This would be removed by introducing a constant k, which is like this: d equals k into s. This k is called as constant of proportionality. Now we'll make the equation of variation using the data given. So speed is 30, distance traveled is 90. Let's put the values. So 90 equals k, the constant, multiplied with speed, which is 30, which gives us k equal to 3. So this is the constant of proportionality, which the value we have solved is 3. We'll use this value in the second scenario, which says we need to find the distance when the speed is 60. So can we say, using this equation, distance equal to k into s gives us distance equal to 3 and speed is 60, gives us the answer as 180 kilometers. Moving on down to the next concept. Now this is reverse of the one we just discussed. It says marks of a student are inversely proportional to the time he spends on his mobile. So we'll say marks are inversely proportional. This is 1 upon t. So moving ahead, we'll write again m equals to k upon t, where we have introduced that constant of proportionality, and you can see whenever two things are in inverse proportion of each other, their product is constant. So we can say m into t is constant. We'll use this in the information given below. So when he spends 3 hours on mobile, he scores 70%, which means 70 the marks into the time taken, that is 3 equals to k. So we get k as 210. Now what would be his score when he spends 6 hours, which means we need to find the score when he spends 6 hours, and we know the value of constant, which is 210, gives us marks as 35%. This is the reverse ratio. Let's have some more questions. The area of a square is in direct proportion to the square of its diagonal. Area of a square whose diagonal is 15. We are given the area 112.5. Find the length of the diagonal when the area is 162. So first of all, we'll make the equation, and it says area is direct proportion to square of the diagonal. That means area is proportional to diagonal square. We can write this further as using the constant of proportionality, area equal to k into d square. So we are given area as 112.5 equals to k into the diagonal, which is 15, gives us d square which is 225, and we can find K as 1 by 2. We'll use this value again to get the final answer. So find the length of the diagonal whose area is 162. So we can say 162 equals to the area equals to the constant, which is half into d square. Solving this equation, we'll get d square as 324, gives us the value of diagonal as 18. Moving down to the next question. So we solved it. Answer is 18 centimeter. The next question. Force of attraction between two unlike poles is in inverse proportion to the square of the distance between them, which means we can say force is inversely proportional to the square of the distance. That is, it's inversely proportional to 1 by d square, which can be written as F equals to K by d square using the constant of proportionality like in the previous question. So now the value is given. If the distance is 8, the force of attraction is 15. So we'll put the values. So can I say F, which is 15, equals to K, which I need to calculate, by d square. D is 8, which means it would be 64. So I'm getting the value of K as 64 into 15. Moving ahead for the second case. Find the force of attraction if the distance between the poles is 2. Now we need to find F, which is equal to K. K is 64 into 15 by the distance between the poles, which is 2. So solving it, it's 32. So 32 into 15, it would be d square. So it will be 2 into 2, and we'll get 16. 16 into 15 gives us answer as 240. Moving down to next question. Distance varies as directly as square root of the height. So distance varies directly as the square root of the height. So d is proportional to root h, which can be written as d is equal to k, the constant, multiplied with root h. Now we'll use the information provided. From a place 100 meters high, the distance is 2 kilometers. So let's put the values. It would be 2 kilometers. So 2 equals the value of k and root h, and h is 100. So this is equal to 2 equals to k into 10, gives us k equal to 1 by 5. Now we'll use this value to find the final answer in the second case. We need to find the height such that the distance should be 6, which means we'll get 6 equals to 1 upon 5 into root h, gives us root h equals to 30. Solving it further, squaring it, we get h as 900. That's your answer. So let's have the next question. The volume of a sphere varies directly as the cube of its radius. That means the volume is proportional to r cube. R is the radius. We can write this as V equals to K r cube, where K is the constant of proportionality. So 3 solid spheres of radii 3 centimeter, 4 centimeter and 5 centimeter were melted and cast into a big sphere. Whenever this kind of a transformation is done, the volume thing remains constant. So we need to find the radius of the bigger sphere. So what we'll do is, we'll find the cubes of these values, and that would be the resultant volume, and then we'll find the cube root of that to get the radius, which means the required volume would be, we'll simply find the cubes. So it would be 3 cube, that is 27, then is 4 cube gives us 64, 5 cube will solve, that is 125. So the total volume of the bigger sphere would be, we'll add these, that would be 216, and since this is proportional to r cube, which means the net, we can say the volume, the radius of the bigger sphere is, say, capital R, this would be cube root of 216, which would be 6. That's your answer. Let's move to the next question. An engine can move at a speed of 56 km per hour without any wagon attached. Reduction in the speed is directly proportional to the square root of the number of wagons attached. So, the information provided is, when there are 16 wagons, the speed is 24. What is the maximum number of wagons that the train can carry? Now, reduction in the speed is directly proportional to the square root of the wagons attached, which means the reduction in the speed would be 56 minus 24. This would be the reduction, is directly proportional to, either we write the sign of proportionality, or we can directly write the constant of proportionality, that would be equal to k. The constant is directly proportional to the square root of the number of wagons attached. So wagons are 16, square root of 16 should be taken. So we'll get 32 equals to k multiplied with 4, and the value of k we will get from this equation is 8. Using this equation in the second scenario, it says, what is the maximum speed of wagons that the train can carry? So the common sense should be, if I want to maximize the number of wagons, let us reduce the speed of the engine to 0, which means we can write 56 minus 0 equals to k, which is 8. We have just solved it. This would be multiplied with square root of w, gives us, we can solve it, this gives us root w as 7, which gives us w as 49. Now, is this your answer? No, it's not. The reason is, at 49 wagons, the speed is 0, which we have taken, which means the train is not moving. For the train to move, we need to reduce this 49 by 1 to maximize the number of wagons. Hence, your answer in this case would be 48, because we need to move the train, and at 49 wagons, the train is not moving. Really interesting question. So moving to the next one. The cost of diamond varies directly as the square of its weight. So we can see the cost varies directly as the square of the weight. So we can write this, cost is proportional to w square, or we can write this as cost equals to k w square. Now, what next? It says, once this diamond broke into 4 pieces with weights in the ratio 1:2:3:4, and when these pieces were sold, the merchant incurred a loss of 70,000. What was the original price? So, this diamond broke into 4 pieces, means if the ratio is 1:2:3:4, can we take that weight as x, 2x, 3x and 4x, which means the total weight of the diamond becomes 10x. We have added all the values. Moving on, when these pieces were there, the merchant incurred a loss of 70,000, which means we need to take the difference of the cost, and it's proportional to square of the weight, which means we'll write the equation as, we'll square 10x, which gives us 100x square, minus, we'll add the costing of these 4 weights. So it gives us x square plus 4x square, then is we have 9x square, 16x square. This becomes the costing after this diamond broke down. So this difference is given to us as 70,000. Now solving it further, we'll get 100x square minus this value in the brackets would be x square, 4x square, 9x and 16x gives us 30x square, which means 70x square equals to 70,000. Gives us the value of x square as 1000. X square value is 1000. So find the original price. Original price was 100x square. This was the original price, 100x square. Putting the value of x square back, we'll get the answer as 100 into 1000, which would be 1 lakh. Moving to the next. So 1 lakh is your answer. Now we have some practice questions for you. You can go through them and the answers are provided. This is the next practice question. This is the third practice question. And these are the answers of these practice questions. For further videos, you can always log on to our website. Keep watching. Thank you.